guy. Morning, welcome to Utico Engineering Services, your house plan market. Today is another beautiful day with construction gist. As you can see, we are going to be looking at a very interesting topic which are titled the concept of reinforced concrete. If you have been close to the site activities, you will discover that our construction activities center on two major materials, which is the steel and concrete. These two materials, they are of different characteristics, so we need to look at why do we combine them in the first place, and how do we combine them. For us that are into the construction industry, does not mean you must be an engineer or you must be an architect before you get the basic knowledge of the reason behind these things. I felt it's something that everyone that is into the construction should be able to know why these things are done this way, even though you don't have the grand knowledge of it, but you should be able to have the basic knowledge of why engineers are doing this are combining this thing this way. And that, I believe, that's going to help in correcting some errors that is done by workmen. Maybe like the iron bender. Sometimes the iron benders, when you ask them to do work, they do the work without the concept of the engineers, or if someone at the site is not a competent engineer, you discover that they need if you have basic knowledge of these things, you should be able to tell them. I think because of the support condition, this reinforcement should be placed on top or below. This is the reason why this topic is very important for our discussion today. If you are joining me for the first time, you are welcome. Please feel free to comment below. Let us get your thought, let us get your opinion about the topic we are about to discuss today. If you have friends that might be of interest to them, you can as well share it to them. So what we are looking at today is the concept of reinforced concrete. The idea behind connecting reinforcement inside of concrete. When you watch closely at the site, you discover that most of our site activities is done around concrete and reinforcement, especially if we are undertaking a story construction project. So it is very important for us to understand why do we connect rod inside of concrete. That's one. Then two, how do we connect it, and where are we supposed to place those rods? So before we get to where, how, and where we are going to place those rods, I want to explain the concept, or rather I want to explain each individual materials and their uniqueness, so that we can have little bit idea of the topic we are going to be working around today. So stay around, guys. So I'm going to start by explaining the concept of the materials we are talking about today. The first material is concrete. Concrete on its own is a composite material that is combined, that is made up of cement, sand, water, and aggregate. The aggregate is what is known at the site as sand and chippings. The properties of concrete, some of them are good for construction purpose, while some of them are not good. If you look at concrete very well, in terms of comprehensive strength, it's very okay. What do I mean by comprehensive strength? If you if you have a concrete, okay, a piece of concrete, for example 1 meter of length, and you lay it on the ground, if you apply force on it, it takes a longer time. In fact, it will resist your force even if you decide to climb on it, provided it's on the floor. If you climb on it, you discover that it's not going to break. But that same concrete, if you raise it up a little and put it on two supports, and you decide to climb on that same concrete without rod inside, definitely it's going to tear apart. Okay, this is what I use this means to explain to you the strength of concrete. So in terms of shears and tensile strength, concrete it's not good in those areas. But another area concrete is good is fire resistance, okay, and durability. It can stand a long time to resist fire, and it's equally durable. It doesn't get bad on time. All right. So when you look at this aspect of concrete, you discover that okay, fine, we might not be able to use it for construction purpose alone, but if it's being combined with steel, it's going to give a perfect result. Why? Because steel on its own is a material that is good in comprehensive strength, is equally good in tensile strength, is good in shear, okay, and is durable. The only area steel is lacking is the fire resistance. Okay, so if you look at it now, if you bring steel and connect it inside the concrete is going to protect the aspect of the fire resistance for the steel, and the steel is going to provide the tensile strength the concrete is lacking. Okay, this is the concept of bringing these two material together to form one particular component that we normally use at the site. But the idea now remains, how or where do we place these materials? So this is a question that needs to be explained, and this is the main focal point of my illustration. So when you get to the site these days, you discover that workmen, builders place their reinforcement anyhow at the site, and this is where the problem lies. So my idea, what I'm trying to discuss today here with you guys, is you need to understand how to place your reinforcement depending on the support level. So the next thing I'm going to be explaining is where do we place our reinforcement. So I'm going to be using some diagrams, as you see now, to explain how we place our reinforcement. Is it going to be at the top? Is it going to be at the bottom? Why is it going up? Why is it going to the bottom? Okay, what is the support condition? All this you'll be getting it as we move forward. If you watch at the diagram, you are seeing carefully, you discover that you have a beam just like this, okay, with two supports. You have a support here and you have another support at this other end. Okay, when I use the word support, I'm talking about pillars. So when you have this beam like this and you have the support at both ends, that system of support is known as simple support. Okay, simple support. So when a load is being placed, when you have a load, when I talk about load, I'm talking about force, equipment, anything that you put on top of this member. Now this is the beam, whatever thing you are placing on top of this plate, and then you have these two pillars that is holding it. Okay, just like you are seeing at the diagram, that beam will bend a little like this. okay, because of this pillar that are holding the beam. If the load is much, it's going to be bending like this, and if you keep placing load on it, it will continue until it deform. Okay, now how do you make this particular beam now to remain straight without bending this direction? Is by putting the rod at the bottom, putting majority of the rod at the bottom. Okay, now once you place majority of the rod at the bottom, you have been able to save that particular beam from getting bad, from deformation. Okay, what happens at the top? You will equally put rod at the top, but not much. So for instance, if the span is much, when I mean span, I'm talking about, for example, there's a pillar here and there's another pillar here. If the distance between this pillar and this other pillar is much, okay, you might need to increase the beam, the reinforcement you are putting at the bottom, to be 3 or more than 3. Now the number of reinforcement that you place at the bottom, okay, can be calculated theoretically. It's not something I'm going to tell you here that you should put 5, but I can only just give you an idea that if you have a long beam, you can increase your reinforcement to 3 or more than 3 at the side. But if you have a short beam, when I mean short beam, for example, a beam of 2 meters, 3 meters, okay, even if you use 2 reinforcements at the bottom, it will still sustain it. Another area you consider is the load that is coming in. So if, for example, the load that is coming in is going to be a very massive load, or the slab by the both sides, slab at this direction and this other, if it's going to be very much, you need to consider the rod that is coming in. But the idea I want you to get is, for a simple supported beam, okay, where you need to put your rod is at the bottom, where you need to concentrate more is at the bottom and not the top. That's the idea I want you to get. And I'm not by any means teaching you so that you go and do it yourself without an engineer. It's always advisable for you to use a competent engineer to do your site activities. Okay, so the next thing I'm going to be looking at is the second kind of support. The second kind of support is a cantilever system. So I'm going to bring in the second diagram so that you can have idea of how the cantilever system is. Now you look at my hand there. If you watch, you see how this is now. At the same time, if you see the diagram on the screen, you discover that the support system, okay, is just a single pillar that is holding the beam. You see it on the screen there. Now, when a load is being placed at the top end there, okay, you observe that as you continue to increase the load, or depending on the weight of the load that you place here, if there's no rod there, if there's no reinforcement at the beam, okay, of this member, it's going to be deflecting in this direction, just as you are seeing it on the diagram. Okay, now if it's moving in this direction, what does it mean? Just like you have your hand, let's say you have your hand this way, how do I position it, and it's moving this direction, it means that you are putting at this top here, you are going to be having a very serious tensile stresses developing at this point here, meaning that if you continue to go this way, this place is going to pull out. So in order to protect this area from pulling out or from getting bad, okay, rod needs to be provided at the top here. All right, then at the bottom here, where you have compression, okay, when this bottom here is the compression, the compressive stresses is developed here, you can provide less rod at the bottom of that beam. All right, so if you watch closely, something like this at the side, if you see something like this, depending on the span, when I use the word span, I'm talking about the length from this pillar here, which is the column position, to the end of the beam. If it is not much, you can put 3 there. Okay, if it is much, you can increase it. But the idea I want to get is where you place it. Is it going to be at the top or is it going to be at the bottom? Now you are able to identify that we can place it. We are going to place, once we have this kind of connection, at the top area is our major point of focus. That is the area where we need to place our rods. Now the number, the amount of rod that you place here is gotten theoretically. I mean the amount of rod and the size of rod that you are going to use here is gotten theoretically. If it's going to be Y12, it's going to be Y16, Y20, and so on and so forth. That will be determined through calculation. Okay, so but the basic thing I want to get here is where you position your rod. So if you are at the site and you discover that you have a support condition like this and the area of concentration for rod is at the bottom, then you know that something is wrong somewhere. You can call the person in charge, if it's your iron bender or if it's anybody, and advise as appropriate as possible. Okay, this is another reason why it is always good for you to use engineer at the site. Okay, getting this area wrong, you might not see the mistake or the effect immediately, but your house, your construction work will not stand good test of time. Because what it means is that if this place is poorly reinforced, if this member is poorly reinforced, this particular beam at this place will suffer. It's going to be undergoing serious deformation. It can be gradually until definitely it's going to deform. Okay, it can result to cracks on the building and so many other effects. So if you watch this building now, you discover that the position at the edge, there's no pillar at that place, but before the edge you see a pillar there, and this other side you see another pillar before the edge, but at the edge there's no pillar. Now the idea, the person in charge of this particular project, what is his own idea is to make sure he has a good edge that will bring beauty to the house without considering the effect of the support condition. Okay, look at the structure, look at the building you are seeing. If you can see very clearly, you see the area I'm trying to point and okay, there's no pillar at that edge. So practice like this is not too good, okay, in our construction environment. But these are the things that we see more often on daily practice. We see them more often without, we don't even take serious about it. Now if the person in charge of this is not an engineer, there is all possibility that at the beam top, for the slab, the reinforcement there is still likely to be just two bars, instead of making provision for the upper one to be more than the lower one. It's likely to make the upper one to still be 2, because the other ones that is coming from the other end is 2 bar, so it's going to take it 2 to the end and 2 to this end. So what's going to be happening there? That particular area there, every load that is there is going to be sending serious tension at the end of that pillar, thereby causing cracks on that particular building with time. Sometimes it's not something that you get effect immediately, but with time it is bound to happen. So that's why we always say, if you want to handle your project, you want to keep your project out, look for someone that you are sure that will follow structural designs. I'm very sure that there's no engineer that will design a structure and decide not to put pillar at the edge. But if that is the case, if the design is based on not putting pillar at the edge, probably because there's going to be window position there, maybe there's a corner window there, then the design for the beam is going to be different. It's going to be designed as a cantilever member, just like I've just explained to you. Okay, so when you see structures like this, it's very easier for you to understand what to do and how to go about it. The next thing I would like to discuss is the next support condition. Okay, the next support condition is what I want to discuss, and the support condition is a position where you see members in this direction. Don't know if you can get it clear. Okay, so where you are seeing a support condition like this now, okay, these are the pillars. Like this is a column, and this is another column, and this is another column. Now if you see, so you can have it in this direction up to about 1, 2, 3, 4 and so on. You can have up to so many columns, and while you have the beam on the columns. Now when you have this kind of support condition, just as you are seeing in that image there, where you have about column 1, 2, 3 and 4. Okay, when you have this kind of support condition, you call it continuous beam. This is a support condition which is continuous beam. All right, so when you have this kind of support condition, the moment you put load on top of this area and this area, okay, and so on and so forth, the middle here tends to deflect. Likewise, this area tends to deflect. But something happened at this point, which you have, where you have here. At this point here, you start having hugging. Yeah, you start have something going up. Okay, this place will be passing through some tensile stress. Okay, at the bottom here, you are going to have tensile stress here. While here, you are going to have compressive strength. Then at this point here, you are going to have tensile strength stresses developing at this top here, between some at a particular distance from this beam to this other beam. You are going to have a tensile stress developing at this area because of the support condition. So that's the way you are going to have it at this point of this pillar, this point of this pillar, and the next one. Okay, but for this now, the area you're going to have it is, you have at this below here, you're going to have your tensile stresses here. At the top here, you have another tensile stresses here. While somewhere here, you have another tensile stresses. Now, from what I've explained to you, I told you that the steel, they are very good in tensile stresses, and the concrete is good in compressive stresses. So where do we put the steel in this kind of connection? Okay, if you look at it very well, the place that you can put the steel is from at the span area. You place your steel, let it be much here. Then at this top area, you place your steel, let it be much. Okay, the same thing with here. But if you get to the site today, most times the iron benders, what they do is they just place their steel at this area. They don't consider the top that's experiencing tensile stresses for a continuous member. I don't know if you are getting me, and this is still the reason why you need an experienced engineer to handle your project, especially if they are contemporary designs. Okay, if they are contemporary designs, you really need someone, not I can build engineer, not I have done it before, but someone that understands structural detailing and structural principles very well, especially if you are undergoing a building project that is contemporary. It doesn't make sense when you are putting money to get so much materials, putting money to pay your staffs, your workers. At the end of the day, you start having failure or poor construction practice at the site. Okay, these are the reasons why I'm bringing this to you, so that at every point in time, you should be able to have good knowledge of what is happening at your site. It is not just enough for you to say you have somebody at the site that is managing your site, maybe a supervisor, but it's always very important for you to know if the person at the site is good enough to handle the site project. These days, what is invoked now is contemporary structure, and most of this contemporary structure, they are designed in a way that if you are not good, if you are not a good engineer, or if you are not a good builder, the reinforcement becomes very difficult. You are going to do it the way you are doing the former kind of buildings, and you are going to get failure at the end of the job. So guys, I want to believe that so far so good, we'll be able to gain one or two things from our discussion today. Like I said before, we have three support conditions. The first one I said was the simple support condition, where you have just two columns. All right, and the next one is the cantilever support condition, and the third one is the continuous support condition. So when you look at all this now, where you can equally ask the last question: where can you find all these support condition? Okay, for the first support condition, where you can the areas where you can easily find them is, for example, when you are entering your entrance porch, where you have two pillars and you have a beam on top of it. That kind of support is simple support condition. Okay, so the reinforcement for that kind of thing is not much. The area of concentration, like I said before, is at the bottom. Okay, for buildings where you have cantilever support condition, where can you find it? You can always find it either at the veranda, at the balcony, where you have one support, okay, controlling the beam. You can equally find it at the front area too, but you always find it either at the veranda at the front, where you have one particular building, one particular column carrying the entire beam of that particular balcony. Okay, these days you still see workers, you see labourers, you see workers placing creating the edge or condition as a cantilever member. It's not a good practice, but if it is done at the site for a particular purpose, maybe because there's going to be a an L window there, okay, or there's going to be something there that you don't want to introduce a pillar there, the next thing you need to do is to understand where you can place your reinforcement and put that reinforcement appropriately in that direction, so that the stresses that will be developed at the support condition will reduce to zero. All right, and lastly is the continuous member. Where do you find this support condition in our construction works? Basically, you find this support condition at the middle of the building, okay, inside the building, where you have different rooms, different connection and different pillars, okay, and beams connecting each of them together. This is where you have the continuous connection. Okay, so when you have that kind of connection, most times if you watch the workman only put, if he's putting two, sometimes they put two reinforcement at the bottom and maybe two at the top. But what needs to be done is, as you are taking care of the bottom, you take care of the top reinforcement where necessary. If this is done properly, you are going to reduce stresses in that particular apartment. Okay, when I use the word stresses, I don't know how to explain it clearly to you, but I'm talking about displacement. I'm talking about pains the building is going to be having. Yes, stresses like pains. Yes, let me use the word pains that particular building is going to be having. So if the pains are too much, it's going to be resulting to cracks. It might not be something that will come up immediately, but it's going to be something that will be coming up gradually until you start seeing it with your eyes that this building is passing through serious stresses. Because there are some buildings that you will see all the body. Okay, maybe the first time they build it, you are not seeing something like that, but after some time, after maybe 1 year, 2 years, you start seeing the body running through different cracks. You know that this particular building is not properly balanced, it's not properly done. Okay, so far so good. I want to believe that we've gained something from today's discussion. I really don't want to make this too lengthy. I just want a situation whereby we can just briefly discuss and see how we can get one or two things from this topic. But hopefully in our next video we are going to be talking about something unique also. Something unique is still going to be about construction gist, construction work. I just want to give this particular segments area all about construction activity. So whatever thing that is happening at the construction site that I can pick out and discuss, I'll bring it up on board so that we can discuss about it. At the end of the day, I would like you to still contribute, bring your input. If there's something that I've not explained clearly for you to understand and you understand it better, you can comment or do a video and send it to me. then I'll be able to still post it and share it on this platform for us to understand. The idea I'm looking at is not just to teach, but is to to see how we can bring theoretical, something that we've done theoretical, then see how we can bring it out practically, so that students of engineering, they can watch it and try to understand, okay, this is what we have been learning in the school, okay, this is the practical aspect of it, and get idea. And I think it's going to make it easier for them too, apart from the students, then the workmen at the side too. This can still give them an edge too, to know where to place their reinforcement. Okay, not every time you want to place reinforcement you just think it's going to be like this. No, you just have to understand, okay, for this kind of connection, this is what to do, and that is what to do. If you are joining me for the first time, please, you are welcome. I hope I've not bored you with this episode of our discussion. I strongly believe that you've gained or you learn one or two things from it. So please, I would like you to share your comment. I would like you to share it to friends that this video might be of interest to. Let them know what is going on this platform. And if you would like to contribute, if you would like to join me one-on-one for structural gist, for construction matters, construction gist, please let me know in the comment section. Thank you so much, and God bless you. See you then. Goodbye.